Howdy, howdy. This is Mr. Potter. In our previous lesson, we were talking about Boolean variables, how we declare Boolean variables, how we can assign them to either a truth or a false state, how we can print out the truth or falsehood of a particular value, or how we can use our logical operators or our relational operators in order to get the output that we're looking for, to find out when a situation is true and when a situation is false. In today's video, we're going to be talking about how to actually use that to determine when some code is run. So what I'm going to do is I'm going to create a real quick prompt here. Remember that if I want a prompt, I have to create a scanner. With use the system.in. And in order to use that scanner, I'm going to need to import java.util.scanner. And then I'm going to get a number from this. I'm going to say int val get scan dot next int. So I'm going to be prompting for I'm going to prompt the user to enter a number. And then they're going to type in a number. And then what I want to do is I want to write code based on the number that they type in. So I'm going to say something like if val is greater than 3. So in other words, the following code runs if val is more than 3. So I'm going to set up some braces, meaning the next segment of code is going to run if this stuff is bigger than 3. So I'm going to do system.out.println your number was bigger than 3. So if I run this, it's going to, since I take care of my errors, system.in so it's going to enter a number, and I'm going to type in a number like 5. 5 is bigger than 3, so it should go to this segment of code and tell me that my number was bigger than 3. Now, if I were to run this program again and type in a number like 2, then what's going to happen is it's going to completely bypass my code. Because val was not bigger than 3, it completely ignores the code between these two braces. braces, and it just marches on. So what I could do is I could kind of say else, and then in braces say system.out.println. Your code, or your number, was not bigger than 3. And so what this allows me to do is to have some code that runs under certain conditions and some alternate code that runs under different conditions. So I can type in a number like 5, and it'll tell me my number was bigger than 3. If I run this code again with an input of 2, then it'll say your number was not bigger than 3. So depending on the input determines which segment of code is going to be run. It's a very powerful tool here. The idea that I could just compare some number to a given number, and solely based on that determination, solely based on whether or not this is true or false. If it's true, some code gets run, and if it's false, some other code gets run. So I have this option here. I could do another if-else statement here. I could say if val mod 2 is equal to 0, then I could system dot out dot print line your number is even, and then I can go down here and say else, and then run this code, system dot out dot print line your number is odd. And so if I type in a number like 6, 6 is bigger than 3, so it should march into this code. And it's going to continue going after the else statement. The else code won't be run, but then this next line of code will be run. And it'll check 6 mod 2. That is no remainder. So we're going to run into this segment of code and ignore this segment of code. So what's happening here is we actually have our code kind of forking in 2 directions every time I hit an if and an else. But then that fork kind of recombines, and we can continue on with our process, with our flow. So everything after the if-else block, everything after this code, it's only going to run one of these branches or the other branch, but then it'll continue on to this. I could put a statement here that says system dot out dot print line this line always gets run. And if I run this, I'm always going to run that line of code. So let me go ahead and stop this and run it again. So if I type in 6, notice what happens is it says my number was bigger than 3. This line always gets run. Your number is even. If I run it again, but I give it 5 as the input, notice 5 is still larger than 3. So it's still going to say your number was bigger than 3, but we go to this other branch that says your number is odd. If I run it again and I type in a number like 2, it's going to tell me your number was not bigger than 3, but this line always gets run, and your number is even, because 2 is an even number. If I run it one final time with the input of 1, okay, 1 is a number that's not bigger than 3. This line always gets run, and your number is odd. So we've got this if statement, and this code kind of runs in one of 2 directions. One of the things that we have at our disposal, though, let me do one more system.out.println line. This code also is always run. There's one other thing that we call nested if else. In other words, the idea that I could have an if something is true, do one thing, else do a second thing, if else do a third thing. So we can kind of connect these ifs and elses to kind of make it okay. So there's one of 3 options or one of 4 options. So what we can do is we can say if val mod 3 is equal to 0, then I can system.out.println your number is divisible by 3. And then down here I can say else if val mod 3 is equal to 1, then I can system.out.println your number is 1 more than a multiple of 3. Else, and then say system.out.println your number is 1 less than a multiple of 3. So looking at this code, I want to kind of block off some stuff here. So I'm just going to block comment from here to here. Just putting a comment here because I wanted it to be able to prompt and then go to this decision making here, and there's really three different branches. Either my number is a multiple of 3 because it's a remainder of 0, or it's one more than a multiple of 3 because dividing by 3 gives me a remainder of 1. Or if I reach this else statement, I really should put a comment here that says, I know what's going on. In other words, val mod 3 is equal to 2. In other words, val is 2 more than a multiple of 3. But it's also 1 less than the next multiple of 3, which is what I have for my output. So if I run this with different input, I'm going to type in a number like 6, and 6 is divisible by 3. If I run it again, I can type in like 7, and I get your number is 1 more than a multiple of 3. And if I type in 8, then it's going to tell me my number is 1 less than a multiple of 3. In this case, that multiple of 3 is 9. Now, I could continue this if I wanted to. I could have put another if statement here and then put another else after this. I can create an entire chain of if and else's to take care of 4 different segments of code, or 5 different branches of code, or 6 different branches of code. However many branches of code I want. And that's what's really powerful about the if-else statement. It allows us not only to execute some code under some circumstances, but it allows us to make a decision as to which branch of code we want to run under different circumstances. And in other words, I could have 8 branches, and each one of those branches is only run under a very specific situation. So one of the things that I can do, I'm going to go ahead and block code some more here. So I'm going to block out everything up to what I've already typed. And I want to use those logical operators that we talked about. So I want to do something like if val is greater than 3 and val mod 3 is equal to 0. Then what's happening is I would system.out.println your number is more than 3 and is evenly divisible by 3. Now, when I hit this else, something's happening here. So either val is smaller, or excuse me, not bigger than 3, or the remainder was not 0. Because I only reach this line of code if both of those things were true. Remember that an AND statement is only true if both of these statements are true. If I fall down here, then one or the other or both could have been false. So I really need to take a look at both of those situations. So I'm going to go ahead and get rid of this comment for just a second. So I'm going to say if val was greater than 3, in other words, if I made it this far, then I would just do system.out.println your number is more than 3. And if I reach this point, I know that it's not greater than 3 because it would have either come out to this branch of code or it would have come out to this branch of code, because here I'm really saying and the remainder is not 0. So if I do else if, now I can check, okay, well, what if the remainder was 0? Val mod 3 is equal to 0. Then if I made it this far, what we have here is that your number is divisible by 3. And then I have one more case here. This else. What's happening here is val is smaller, or not smaller, but not greater than 3. And val is not evenly divisible by 3. If I've made it down to this branch, because we're looking at 2 different statements. One logical statement saying that val is bigger than 3, and the other logical statement saying its remainder is 0. If I've made it through this branch where they both are true, or this branch where the first is true, or this branch where the second is true, then I make it down here and neither has to be true. And so what I would do is I would just do system.out.println neither is true. So if I run this, I can type in numbers. I can type in a 6, in which case my number is more than 3 and is evenly divisible by 3. I could type in a number like 7, where my number is just more than 3. I could type in a number like 3, now 3 is not bigger than 3, so we're going to fall down past this branch, past this branch, and down to this branch, where your number is divisible by 3. And if I type in a number like 2, then it'll tell me that neither is true. I'm not greater than 3, and I'm not evenly divisible by 3. This notion of using ifs and elses to run certain code under certain situations is one of the pinnacle cornerstone points of computer science. The idea that we can make decisions and run code based on those decisions is what really makes true dynamic programming possible. So once again, this is Mr. Potter. Thank you for watching. Have a great day.